Alright, today we're going to be focusing on completing the square. Now this is a very important unit for both pre-calc and your life beyond pre-calculus. So let's start with an equation. X squared plus 4x plus 3 equals 0. So let's say you were just given y equals x squared plus 4x plus 3 and you were trying to find the roots. You were trying to find when y equals 0. So naturally, what you're going to want to do when you try to find roots is you're going to try and factor. But you'll notice right off the bat that this expression right here is not factorable. So we need to introduce a new method called completing the square. So here are our methods by completing the square. First thing we do when we complete the square is we look at a, the coefficient of x squared. In this particular case, a is 1. And the first thing we do is we divide everything by a. Since a is 1, everything divided by 1 is still itself, so nothing changes. The next thing we're going to do is we're going to rewrite this while moving the 3 to the other side, equals negative 3. Okay? So I'm going to move this equal sign a little bit further away so I can have a little bit extra room here for our next step. Next, what I need to do is I need to take my b term, the coefficient of x, and I need to do this to it. I need to find b over 2 squared, and I'm going to need to add that to both sides. So b is 4, 4 over 2 is 2, and I'm going to need 2 squared. So what I'm going to do is I'm going to add 2 squared to both sides, okay? And this keeps my equation the same because whatever I did to the left, I did to the right. Now, what I have here on the left is something that is factorable, okay? So the way this is going to work out is I'm going to try and factor it. I'm going to resolve my 2 squared and I'm going to return it as 4. So now I can factor this. What adds to 4 but also multiplies to 4? Why, that is 2 and 2. So now we can factor by the AM method. We're going to start with our two sets of parentheses. We're going to put x at the beginning of one, positive 2 in one, positive 2 in the other. So now our little expression right here has been completely factored. And that now equals negative 3 plus 4. But notice here that these are two of the exact same expression. So I can rewrite this now as x plus 2 squared equals negative 3 plus 4, which negative 3 plus 4 equals 1. So now, if I were trying to find the roots, like I suggested initially, we would need to solve for x in this case. We would take the square root of both sides, and we get x plus 2 equals plus or minus rad 1. Remember our plus or minus because the square root of something can be either positive or negative. And the square root of 1 is, of course, 1. So let's write that as plus or minus 1. Okay, so that therefore splits us into two equations, one being x plus 2 equals 1, the other being x plus 2 equals negative 1. And now we solve for our x values. So now we're going to give ourselves a little bit more room so we can isolate x. We have subtracting 2 from both sides, x equals negative 1, and subtracting 2 from both sides again, x equals negative 3. So these are going to be our two roots, and that is how we use completing the square to solve for the roots of an expression we cannot factor. Let's continue with another example. So let's say I told you to complete the square on x squared plus 6x, okay? How would we do that? Well, first of all, we look at our a term. It's 1, so we don't need to do anything. Then we look at our c term, our constant, and we move it to the other side. But in this case, there is no c term, so we move right to the final step, which is we look at our b term, which in this case is 6, and we compute b over 2 squared. Okay? Now, 6 over 2 is 3. 3 squared is 9. But I'm just going to keep it as 3 squared so I can illustrate for you the usefulness of this method. So now that I have my equation in this form, I am going to be able to just write my factorization like this. It's going to be x plus 3 squared. And that's all I need to do now. Okay, it's going to be my first term right here. I bring that in. Whatever symbol is in front of my b term, I'm going to bring that in. My final c term, I'm going to bring that in, and the squared above my c term, I'm going to put that outside. And it will always be an answer in this form. And if you want to work through it the regular way, if you want to really factor out x squared plus 6x plus 9, you'll see what adds to 6 but multiplies to 9, 3 and 3, and you'll see very quickly that the theorem holds. X plus 3 equals x plus 3 squared. And of course, we're going to bring down our 3 squared, which is 9. And now we can continue solving for the roots back up here. So we're going to take the square root of both sides, x plus 3 squared, square root. The square and the square root are going to cancel out, equals rad 9 plus or minus, which is going to leave us with x plus 3 equals plus or minus 3, x plus 3 equals 3, x plus 3 equals negative 3, and now we're just going to isolate our x. One case is x equals 0, another case is x equals negative 6. And there we just found our roots of this function. Okay, so I'm going to give you guys another problem. X squared minus 8x plus 10 equals 0. So feel free to pause the video right now and try and work through this on your own, and then come right back to me so we can work through it together. Okay? So first and foremost, our coefficient in front is 1, so we need to do nothing there. Next, we look at our c term, the constant term, and we got to move that to the other side. X squared minus 8x equals negative 10. Okay, now we need to complete the square. We need to compute our b over 2 squared term. In that case, b is negative 8, b over 2 is going to be negative 4, and we are going to be left with negative 4 squared. Okay, so plus negative 4 squared. And so now we're going to do our little trick when we do completing the square, which is we're going to set up our one set of parentheses. We're going to bring down our x. We're going to bring down whatever sign this is. We're going to bring down our number inside the parentheses, and we're going to bring down our squared on the edge right here. And that is our factored form. But we have to remember that if we added negative 4 squared to this side, we need to add negative 4 squared to this side in order to keep both sides equal. So now our equation becomes x minus 4 squared equals negative 10 plus, what's negative 4 squared? 16. Therefore, x minus 4 squared equals 6. And so now, to continue solving for the roots, we're going to take the square root of both sides. Square root and the square cancel out, and we're going to be left with x minus 4 equals rad 6. Don't forget the plus or minus. So that's going to break down into x minus 4 equals rad 6, and x minus 4 equals negative rad 6. So now at this point, we're just going to simplify these down into x equals rad 6 plus 4, and x equals negative rad 6 plus 4. So at this point, you could either leave it like this, or you could go one step further and take your calculator to compute what rad 6 is. Rad 6 is going to be 2.45, and we can use that to compute the actual decimal value of x. So that's going to be x equals 2.45 plus 4, and that's going to be x equals negative 2.45 plus 4, which is going to result in x equaling 6.45 and the other x equaling about 1.55. Those are your final roots. So now I'm going to give you guys one more thing to practice with. Well, I'm going to walk you through this one, and I'm going to give you another one to practice with. We're going to go through 2x squared minus 8x plus 9 equals 0. So we get some practice with a actual coefficient here. So like I said before, first thing we got to do is we got to divide everything by this coefficient. So this becomes x squared minus 4x plus 9 over 2 equals 0. Okay? Now we move the constant to the other side. X squared minus 4x equals negative 9 over 2. And now we need to compute our b over 2 squared. Negative 4 over 2 squared is going to equal negative 2 squared. We're going to put that right here. Don't forget to add it to both sides of the equation. That's a source of a lot of mistakes kids make. Now we're going to rewrite this using our little trick for factoring. We're going to bring down our x. We're going to bring down whatever sign this is. We're going to bring down this number. And we're going to bring down our squared. Okay? So the left side becomes x minus 2 squared equals negative 9 over 2 plus 4. Now we know 4 is going to be the same as 8 over 2, so the right side of our equation now becomes negative 1/2. And let's rewrite it up here in the top right. X minus 2 squared is equal to negative 1/2. So now what we do here yet again is we are going to take the square root of both sides. Square root cancels with squared, and the square root of this guy. Now you'll notice here that we have a negative inside our radical. So this is going to give us an imaginary number. So this is going to simplify to plus or minus I over rad 2. So we have imaginary roots in this case. And that's going to leave us with x minus 2 equals I over rad 2, and x minus 2 equals negative I over rad 2, which if we rearrange our equation, those we just add 2 to both sides, and we are left with one root is equal to I over rad 2 plus 2, the other root is equal to negative I over rad 2 plus 2. And now here I'm going to be giving us an equation so that you guys can pause the video, work on the little thing, complete the square, find the roots, and then you're going to come back to me so we can do it together. Okay? Go ahead. So again, we've got a 3 right here. We're going to divide everything by that number to get x squared minus 5 over 3x minus 7 over 3 equals 0. Okay? Now we got a constant, we got to move that to the other side, and we're going to be left with x squared minus 5 over 3x equals 7 over 3. Now let's do our little completing the square business, our b over 2 squared. So b is going to be 5 over 3, and we're going to divide that by 2. That's going to leave us with 5 over 6 squared. Okay, so we're going to rewrite our equation as x squared minus 5 over 3x plus 5 over 6 squared equals 7 over 3 plus 5 over 6 squared. So now I'm going to rewrite these with my parentheses trick. It's going to be x minus 5 over 6 squared is going to equal 7 over 3. I'm going to rewrite that as 14 over 6 plus 5 over 6 squared. And now what I'm going to do is I'm going to compute this, which is going to be equal to 14 over 6 plus 25 over 36 once I compute my square. So now I have two fractions with different denominators needing to be added. So I'm going to make sure my 14 over 6 gets to the same denominator by making it 14 times 6 over 6 times 6, which now becomes over 36 plus 25 over 36. And 14 times 6 is going to be 84. That's 84 over 36, which is going to result in 109 over 36. So now I can rewrite my equation from up here. X minus 5 over 6 squared equals 109 over 36. And now I should be free to take my square root of both sides. So this is going to leave me with x minus 5 over 6 equals plus or minus, don't forget that, our rad 109 over 36. Now this radical can be rewritten as rad 109 over rad 36, and we all know that rad 36 is equal to 6. So we're going to put that in there. And using a calculator, if you want to compute this in decimal form, or if you don't have a calculator, you can leave it as the radical. Anyway, let's keep moving. X minus 5 over 6 equals rad 109 over 6, and the other instance being x minus 5 over 6 equals negative rad 109 over 6. So we're going to take our negative 5 over 6 and we're going to add 5 over 6 to both sides. So these are our two roots, okay? And if you feel so inclined to plug rad 109 into your calculator, then please do so, and you would come out with the decimal forms of these roots. Alright guys, that should be it for the video. I really appreciate you tuning in. If you ever need help, join the Discord server. In the meantime, enjoy life.